Okay, so sorry the video stopped and I kept going, I didn't realize. So let's just talk through what we have here. Okay, so we listed these out, okay, and we found an equation where it does not have time, but it does contain the y final. Okay, so it was a velocity final in the y equals velocity initial squared plus 1/2 times by acceleration, then it was a delta, so y final minus y initial. Y initial is 0, y final is 0. Okay. Now I'm going to take this initial, velocity initial, and subtract it to the other side. So then that will set equal to 2 times by acceleration times by y final. And remember, that's what we're looking for. So I'm going to divide by the 2 and the acceleration. Keeping in mind that this negative sign is outside of the parentheses. We don't have like this negative attached here and then squaring it and losing that negative sign. It stays there. It cancels with the negative acceleration. Okay. And so when I plugged all those numbers in, I got 0.86 meters. Okay. Now, that was the maximum height. To figure out the time, I chose an equation where I had the time component. Okay. And I chose one that didn't have the y final, because we calculated that. It'd be nice if I could just use numbers from here. And I was able to do that, but sometimes that's not the case when we have to use that calculated number, and that's fine. So velocity final equals velocity initial plus acceleration multiplied by time final. So our final velocity in the y is 0, and we had some initial plus the acceleration of y multiplied by time final. So I rearranged this equation to solve for time, and I got 0.42 seconds. But just a reminder, this is to get to the apex, and it's saying flight time of the ball, and that's only half of the flight. And since we're going from flat ground to flat ground, we can assume that the time it took to get this far is the same amount of time it'll take to go that far. So it would be this time component multiplied by 2, and so we'd have 0.84 seconds for the entire flight. Okay, now, example number 2. Jack be nimble, Jack be quick, jump. Jack jump over the candlestick with a velocity of 5 meters per second and an angle of 30 degrees to the horizontal. Did Jack burn his feet on the 0.25 meter high candle? Okay, so assume he jumped so that he'd be at the top of the arc when he was over the candle. So let's draw a picture, establish an origin, make a list of knowns and unknowns. There's our path there. There's our candle. Okay, and we're going to say where we started is going to be our initial position, our 0, 0 point as well. And then the final will be that very, very top. We want to know what's going on right there. Okay. Now we have an initial velocity of 5 meters per second. And then velocity initial in the y and velocity initial in the x with an angle of 30 degrees. Okay, so let's use our trig skills to solve for velocity initial in the y and velocity initial in the x. The y is opposite from the angle, so I'll take my hypotenuse and I'll multiply that by sine because it's opposite of the angle. Okay. So then when I plug that in, I'm going to take 5 times by the sine of 30, and that gives me 2.5 meters per second, and then y and velocity initial in the x is going to be the hypotenuse multiplied by the cosine of 30. And so then 5 multiplied by the cosine of 30, 4.33 meters per second. And now we want to know the height, just like before. Okay, so we have x components and y components. X initial would be 0. We don't know what x final is. And then let's see, time velocity initial in the x we solved for. It's a 4.33 number. Velocity final in the x is the same because the acceleration is 0. We don't know the time component. Okay. In the y direction, y initial is equal to 0. Y final is what we're solving for. Velocity initial in the y we calculated, 2.5, not squared. And then velocity final in the y we don't know. The acceleration negative 9.81. And then we don't know the time. Okay, so we should solve, let's see, I listed equations right here. I want to know this, and I'm trying to see if we solve for the time component here. Yeah, let's use the x to solve for time, and then we can plug it in over here. Okay, so do we have enough information? No, so we need to make that assumption. Okay. Oh, sorry, this is what I was missing. We're at the very top of the apex, and anytime that's the case, the velocity final in the y is 0 meters per second. Okay, so now I could find an equation, I could use that second equation to solve for this. Then I don't have to figure out the time component. So I could use the second equation where velocity final in the y is going to equal velocity initial in the y plus the 2 times by acceleration and then that delta. So velocity final minus velocity initial. The velocity should be y final minus y initial. Okay, and so now let's see, we have y initial is 0, velocity final is 0. I'm going to subtract that initial, so negative velocity initial in the y, and that's going to equal 2 times by acceleration times by y final, so I'll divide by that. That'll tell me y final, so let me plug those numbers in. Okay. Y final so I'm going to take the negative 2.5. I'm going to divide that by 2 times by a negative 9.81. And so I'm getting a final of 0.127 meters. And so did Jack burn his feet? If the candle is 0.25 meters, yes, he didn't make it over the candle. He could only go this high, not that high. Okay, where are we at time-wise? Okay. So, on example number 3, for my online students, we're not going to worry about the types of questions where we're starting from a different height than where we're ending, okay? So for my in-person CE physics students, and my in-person physics students, we're going to work on these kinds of problems in class, and I'll be sure to record a video on these kinds of problems and have that posted to our Canvas page, but it won't be on the virtual physics course. Okay, so let's keep going then. Let's look at example number 4. Emmy kicks a soccer ball at rest on level ground, giving it an initial velocity of 7.5 meters per second and an angle of 32 degrees. Okay, so we have soccer ball kicked in the air, it comes back down. That is going to be my 0, 0 point. My initial velocity is going to be 7.8 meters per second. There's an x and y component. And we have an angle of 32 degrees. How long will the ball be in the air? How high will the ball go? What will be its range? Okay. So we're going to say this is our initial, that's our final at the apex. We're going to use our trig skills to figure out y initial, velocity initial in the y, velocity initial in the x. And then we're going to make our list of knowns and unknowns. Okay? So velocity initial in the y is going to equal that initial velocity sine of the degrees, and so I'll calculate a number in a moment. Velocity initial in the x is going to be the hypotenuse multiplied by the cosine of that angle. So we have a 7.8 times by the sine of 32. And then I'm going to do cosine. Now let's make our lists of knowns and unknowns. So in the x direction, x initial is equal to 0. X final, we don't know that distance, right? Velocity initial in the x we just calculated. Velocity final will be the same. Acceleration is equal to 0. We don't know the time. Okay. Y components, y initial is equal to 0. Y final is the height there. Velocity initial in the y we calculated. Velocity final in the y, we don't know what that is. The acceleration is due to gravity. And then we don't know the time component. Okay, so we want to know how long will the ball be in the air. So we're going to solve for time. Oh, we're at the apex, so that velocity final is 0, because we're at the very top of our arc there. Second. All right, okay, so now let's use this information to solve for time. So we want to pick an equation that does not contain the y final. So I'm going to choose that one we've been working with a little bit. Actually, no, we want one that has the time component. So I'm going to choose that very top one. That one's simple. So velocity final in the y equals velocity initial in the y plus acceleration multiplied by time final. Okay. This is 0. So that'll subtract over. And then we're solving for time, so we'll divide by acceleration. And the acceleration is a negative 9.81. Okay, so I'll take that 4.133 number, divided by 9.81